Water properties are characteristics such as the tides, salinity, temperature, and turbidity. Tide is the rise and fall of sea level controlled by the combined effects of the gravitational forces of the moon and sun and the rotation of the earth. All coastal habitats are controlled and affected by the tides. Here in southwest Florida, there are 2 high and 2 low tides every day. On average, about every 6 hours, the tide will be either high or low. Our average tidal change is roughly 2 feet, although at some times of the year it can be as little as just a couple of inches. At other times it can be as much as almost 4 feet. All of the fish, wading birds, and dolphins, to name a few, schedule their day around the tides. Every month the full moon gives us our most extreme tide. For the year, the summer and winter solstices move the most water. The summer solstice is the day when the sun is at its highest point in the sky, which is the first day of summer. The winter solstice is the day when the sun is at its lowest point in the sky, which is the first day of winter. The full moon nearest the solstices will usually create the biggest tides of the year. The closer to the North or South Pole, the more extreme the tides will be also. The world record is in the Bay of Fundy in Canada, where the tide range can be over 50 feet. The closer to the equator, the smaller the tidal range will be. Let's start at the low tide in southwest Florida. We will see more of the beaches, mangrove roots, and sandbars because the water level will be at its lowest. Then the water will begin to move as it floods in from the Gulf of Mexico. Approaching high tide, the mangrove roots and many of the sandbars will disappear underwater. At high tide, the water will stop moving, which is known as a slack tide. Shortly after, the water will begin to move the opposite direction. The water recedes back into the Gulf once again, exposing the roots and sand. All marine life is affected by the tides. One example are coquinas. Coquinas are a small bivalve that only lives on the beach where the water meets the sand. As the tide rises, they migrate further up the beach, and when the tide drops, they move back down, always staying at the water's edge. Fish is another example. They're always using the moving water to their advantage. They will move further into the estuary when the tide rises, and back out towards the Gulf when the tide falls. Dolphins are also affected by the tides. They'll use the tide flow to aid in their transportation. They will also be seen fishing in locations where the current is strongest from the tide.
Hi kids, we're here today. We're testing the salinity of the water, and the salinity is how much salt is in the water. Now, we're on the backwaters, but this is connected to the Gulf of Mexico, which is all marine, and all marine water has salt in it. Usually averages around 35 parts per thousand. And what that means is if we had 1,000 drops of water, 35 of them would be salt. So pretty small amount, but definitely enough to where you could taste it. What we have here, it's a pretty simple tool. Kind of looks like a telescope. It's called a salt refractometer. And what it does is you take the water, whatever water you want to test, drop it on to this little slide here, and it will refract the light through the water, and it has little gauges through the eyesight where it'll tell you how salty the water is. It's a really cool tool. So what I'll do is I get my little dropper and I'll reach down into the water here and just suck up just a little bit, just a few drops. Open up our little glass here, drop it right on the opening, close it up, and now we'll hold it up to the light, read right through. And yep, about 36 parts per thousand. So that tells us that the water here, even though we're behind the barrier island in the estuary, has the same amount of salt in it as the Gulf of Mexico. So that's probably due to lack of rain. It allows the tide to push in the salt into these backwaters, making it the same salinity as the Gulf, about 36 parts per thousand.
And remember, dolphins can't drink the salt water because they would become dehydrated. They get the fresh water from the fish that they eat.
This is a Secchi disc. It's a very simple tool used to measure the turbidity. And turbidity is how cloudy the water is. So here in the mangrove forest, there's lots of leaf litter and sediment and mud that washes up into the water. And that makes it very turbid. Well, with this disc, very simple, black and white triangles, we drop it into the water, which is marked by 1 foot increments. So that's 1 foot deep, that's 2 foot deep. We'll slowly lower it into the water, and once it hits the water, we want to watch until we can't see it anymore, until it's no longer visible. Still see it, and it's about to disappear where you can't see. Okay, that's completely out of sight, so we'll get a good eye on where the line is just at the surface of the water. You see right where that wet mark is, right here. Then we can count and see. We have 1 foot, 2 foot, just about 3 feet. So that means that the water is 3 foot turbidity. So if we are underwater, we can see 3 feet away from us, and that's about it. So not very clear water, pretty characteristic of the mangrove forest.
And even though they have great eyesight, the dolphins here are not relying on it as much as the ones in the clearer ocean waters. This is our temperature gauge, gives us an accurate reading anywhere in the water. The temperature is how warm or cold the water is. Here in southwest Florida, it ranges from low 50 degrees Fahrenheit to the low 90 degrees Fahrenheit. It is an ideal range for the dolphins, which allows them to stay year-round. The local fish species will move according to the temperature, changing the species found in our area. This will affect the dolphins' movement and feeding patterns. So we see that all of these water properties combined, including tides, temperature, salinity, and turbidity, are causing the habitat to constantly change, having an enormous effect on the wildlife in our coastal environment.